But I came here in 1997 and we set up the Hydro-Environmental Research Centre. At that time, renewable energy, at least marine renewable energy, was not a big issue here in Wales. Well, the UK has to meet its renewable energy obligations by 2020. Those are fixed by the European Union, and then there are 2050 obligations. And the Severn Estuary has the second highest rise and fall of tide in the world and very large currents. So the government and industry are very enthusiastic about capturing as much energy as possible from the Severn. Historically, we've worked mainly in the UK with horizontal axis turbines. And the problem with the horizontal axis turbine, it requires a large depth, typically 30, minimum 30, and more like 40 metres below low tide. And it requires a very large current, typically 2 metres per second. There are very, very few locations in the Bristol Channel and Severn Estuary where you could site such a turbine. We're doing a lot of work at the moment in our laboratory, FLU, led by Professor Torsten Stoser. And he has designed this turbine which his group are refining in the FLU. And this flume was based on original design characteristics that resemble those in the Severn Estuary.
Well, tidal stream energy is probably 20 years behind wind energy, mainly because of the harsh environment it's operating in. So we're trying to put a device into a stream, into a free stream if you like, and then move or use that movement to generate electricity or to extract the hydrokinetic energy that's in this body of water. So the advantage of the turbine that we're researching right now is that it's vertical axis as compared to the traditional horizontal axis turbine that you find in wind, for instance. It is bidirectional or omnidirectional if you want, so it doesn't really matter where the current comes from, so it rotates no matter the direction of the flow. Well, the major challenge is to go from a laboratory scale model into the estuary or into a real world. So we're complementing our laboratory tests with computational fluid dynamics, which allows us to look into the details. We look into the forces and we look into how the turbine or the rotor interacts with its environment.
The key objectives of this project are to deliver carbon-free renewable energy, which is totally predictable. We can predict it tomorrow, next week and 10 years from now, and that's a huge advantage to engineers, planners, government, economists and so forth. And in particular, I think it offers jobs here in Wales for a huge potential global market in capturing marine renewable energy from tidal stream currents.
Well, as a scientist, I would hope that at some point in the future, this turbine is going to be used as a source of electricity. And short-term goal is now to move the laboratory model into the real world, see how it's operating, see whether it still provides the same efficiency and how it fares with the harsh environment.